Today we're going to look at lesson 5.1, solving systems of linear equations by graphing. Now, some of those words should sound familiar to you, like linear equations. Just as a quick review, if we were graphing a linear equation, what would it look like on a coordinate plane? A line. Very good. It's a linear equation, so it's a line. Now, we have learned three different forms of lines, or formulas. Maybe formula is a better word. What are the forms or formulas that we have learned for linear equations? All right, what is that called? Slope-intercept form. Y equals mx plus b. All right, somebody besides Sam, give me another one. What is that one called, Chelsea? The point-slope formula. All right, everybody say the point-slope formula with me. Y minus y sub 1 equals m times x minus x sub 1. Very good. And the third one is actually the first form we learned back in chapter 3, I believe. Does anybody remember that form?
Standard.
Connor?
Y minus y over.
Well, that's the slope formula, but I heard it over here. Standard form. Does anybody remember standard form? Say it. Very good. AX plus BY equals C. Now, today we're going to be looking at systems of linear equations, and there's two forms that you're going to see. You're going to see the standard form, and you're going to see the slope-intercept form. Okay, you're not going to see point-slope form, but I just wanted to make sure it was still in there somewhere. All right, look at the essential question. It says, how can you solve a system of linear equations? So a linear equation, and we just talked about this, is an equation with an x and or a y whose graph is a line. And I gave you an example, y equals 3x minus 2. What form is that equation in? Y equals 3x minus 2. Slope-intercept. Okay, y equals mx plus b. Now, the solution of an equation. If we wanted the solution to that equation, it would be one point that when plugged in makes a true statement. Now, here's my question. The word point right here. How do we represent a point on paper? And don't say a dot. That's not what I'm talking about. How do you represent a point? If you're going to put a point on a coordinate plane, what do you need? An ordered pair. So, above the word point in your notes, it would be a great idea because you need to understand the solution that you're going to be looking for today is an ordered pair. Okay? Now, a system of equations. This is what we're covering in the next 3 sections, at least. A system of equations. It's two equations that relate to one another. Now, it's important. I want you to highlight where it says two equations. When you get to Algebra 2 later on down the road, there are a system of equations that have 3 equations in them, 3 different variables, but we are only going to be dealing with 2 equations this year. All right, but a system has 2 equations that relate to one another. Now, what is the solution of a system of equations? Again, it is one point that when plugged in makes both statements true. If the system has 2 equations, the point has to make both of them true. Now, again, above the word point, I would put the little ordered pair XY to remind myself my solutions today are going to be ordered pairs. But also, I would highlight where it says both. You have to remember that the point makes both statements true. Now, that's if you're given a point and you're going to plug it into the equations. But what happens when you graph the system of equations? The point of intersection is your solution. So I need you to make sure that this is in your notes, and I make sure that you highlight it. You're adding it into your notes, all right? I did not type it in for you, so you're adding it to the end of the definition, and then I want you to highlight point of intersection. So it's either a point you can plug in and it's going to make both statements true, or it's the point where your 2 lines intersect on a graph. Now, example number 1. Tell whether the ordered pair is a solution of the system of linear equations. So they've given you an ordered pair, and they're asking you if it's a solution to the system of equations. So here's what we're going to do. We're going to write both equations, we're going to rewrite them, and we're going to rewrite them side by side. So 2x plus y equals 0. Leave a little space, and then negative x plus 2y equals 5. All right, there's too much work for us to try to stack them on top of each other and squish all of our work between them. So we're going to put the two equations side by side. Now, let's look at the ordered pair for just a second. We have a 1, -2. Which of those numbers represents x? The 1, and which one represents y? So again, if you still struggle with that, go ahead and make a little note for yourself. The 1 is the x, the -2 is the y. Now, when we have plugged things in the past into an equation, we plug them inside of what? Parentheses. Good. So let's do that here. We have 2. What's going in place of x? 1. So we're going to plug it in parentheses. Plus, what's going in place of y? And of course, we keep bringing down what we're not using. So we bring down equals 0. Now, you got to remember order of operations. What do we do first? Because this has multiplication and addition in it. We multiply. So what are we multiplying? Reagan? 2 times 1, which is? 2. Now, we have plus -2. Is it necessary to have a plus and a minus sign? No. So we can just bring down the -2 and, of course, equals 0. Now, please don't stop here and say, oh, Miss Johnson knows that I know that 2 minus 2 is 0. All right? You'd be surprised. I have people write down that 2 minus 2 is -4. So don't stop because you're not finished. What is 2 minus 2? 0. And then we bring down equals 0. Now the question, does this make a true statement? Yes, it does. So we're not done. We can't say it's a solution because we have to now go plug our values into the second equation. But before we do that, let me ask you a question. What if this had come out to be a false statement? Would it be necessary for us to plug the points into the second equation? No, because what does the definition say? It's going to make both equations true. All right? But this one was true, so we're going to keep going. All right, bring down that minus sign. Be careful because it's already in the equation. What are we plugging, Logan, in place of x? 1 plus 2. What are we plugging in place of y? -2. And, of course, we're bringing down the rest of the problem. All right, what do we do first? We multiply. So let's just bring down -1. We can get rid of the parentheses now. What is 2 times -2? And it equals 5. What is -1 minus 4? -5. And we bring down equals 5. Now, is that a true statement? No. So we would draw a line through the equal sign. And we're going to go answer the original question. Is the ordered pair 1, -2 a solution to this system? Not a solution is the answer that we're going to box in. Now, even though it's the answer we're going to box in, it's not the only thing I'm looking for. I'm looking for the proof. So all of that work that we've put down on the paper, that is the proof. So please make sure you show me that work when it comes time for quizzes and tests. Start letter B, we're going to write the two equations down. So we have y equals 3x plus 1, and we have y equals -x plus 5. Connor, what was the x value for this problem?
1.
And what was the y value?
4.
All right. So we plug in a 4 for letter y. It equals 3. We plugged in a 1 for x. And then we brought down the plus 1. All right, Connor, what did you guys do next?
So what I multiplied 3 times 1 because it's in the parentheses, and that just equals 3. Then you add the 1 to it.
Okay.
4 equals 4.
4 equals 4. So was the first statement a true statement? Yes. So we got to go to the second equation, and we got to do the same. We're going to plug a 4 in place of y. Hopefully you were careful. There was already a minus in the equation. And what did you plug in place of x? 1. All right. Lily, what did you guys do next? Well, you got a little ahead of yourselves because you have a negative and a 1. What does that make? So we can just bring down -1 without the parentheses. And now we do the math. What is -1 plus 5? 4. Is that a true statement?
Yes.
So it made both statements true. So is it a solution?
Yes.
It is. So we're going to write solution. Since we wrote not a solution on the other one, we're going to write solution on this one. Now you'll see in your notes that I've given you some information on how to solve a linear equation by graphing. Now we are going to use Desmos, okay? But I gave you this in your notes just in case, all right? What if you forget your phone? What if Mr. English doesn't have any iPads for me to borrow? All right. Can you do these problems without Desmos? And the answer is yes, because look at what you're going to do. You're going to put the equations into slope-intercept form. What is slope-intercept form? Y equals mx plus b. Once it's in that form, how did you learn to graph these? What would you graph first? The y-intercept, okay? And then once you have the y-intercept, you would use the rise over the run. Very good. So slope-intercept is y equals mx plus b. You would plot the y-intercept first and then use the rise over the run to plot you 2 more points. Now, look at step 2 though. It says graph both equations on the same graph. Why would it be necessary to graph both equations on the same graph? Well, we got to find the solution, and what did we learn, or what did we write into our notes already today? What is the solution to a system? The point of intersection. If the 2 lines aren't intersecting, we can't find a solution. And that's what step 3 says. After you've graphed both equations on the same graph, you find the point of intersection. And then if you wanted to check your answer because you don't have Desmos and you're not really sure, take your point of intersection, plug it into both equations, and make sure it makes a true statement. So we're going to use Desmos, but I wanted to make sure this was in your notes just in case. All right, so grab your phones, open up to Desmos, lay your phones flat on your desk so that only Desmos is open, and let's look at example 2. It says solve the system of linear equations by graphing. Now here's the beauty of Desmos. Desmos recognizes standard form and Desmos recognizes slope-intercept form. So when you're plugging these equations into Desmos, you can plug them in exactly as you see them on the paper. All right, so what is the first equation for letter A? Y equals x minus 2. Now, let's all breathe a sigh of relief because y equals x minus 2. That's all we got to put in there. We don't have to do a boundary. We don't have to do a boundary line. We don't have to decide if our points are open or closed. We are back to graphing a straight line. Okay? But how many points have I asked you to put on your paper when you're graphing a straight line? Nope. 2 was when we were doing pieces. 3 is when we're doing a full line. So let's find some exact points. Remember, you can zoom in, you can zoom out, you can move this graph around, but let's find some exact points. But before we do that, let's go ahead and just graph the other line. What is the equation of the second line for this problem?
Y equals negative x plus 4.
All right, y equals negative x plus 4. Okay, so there is one very obvious point. Usually I say pick whatever points you want, and I still feel that way, except for the one point that has to be on your graph. What do you think that point is?
-2.
Give me coordinates. One number isn't a point. I need an ordered pair.
0, 0.
All right, 0, 0 is not anywhere on either of our lines, so that wouldn't work.
Oh.
Look at your graph.
4, 0.
Okay,
3, 1.
all right, 3, 1. Why would 3, 1 be a mandatory point? That is your point of intersection. That ultimately is your solution. Okay, so that point has to be on your paper. Also, once you've plotted that point, you only need 2 more points for each line. So Ashton, look at the blue line. Give me a couple more points. Now, here's again just my suggestion. I would choose a point above the point of intersection and I would choose one below it. That way my line is always long enough on my paper. Okay, Ashton, can you give me another point on this graph?
4, 0.
All right, 4, 0. And I need one more.
0, 4.
0, 4. 4, 0 and 0, 4. Perfect. Now, when you draw your line through the points, we're back to having full lines. So what has to go on each end? An arrow. All right, your arrowhead needs to go on each end. Now, what about the red line? Javon, we've already got 3, 1. What's some other points on the red line?
2, 0.
All right, 2, 0. I like it. It's below the point.
And then 4, 2.
4, 2. Love it. All right, now look, sometimes Desmos likes to be difficult. So do you know that you can always go over here and you can actually type in a point and tell it to label it and it will label it for you. So if you're ever unsure if you think that point is on the line, type it in and see. It'll put it up there for you. Okay? But that was perfect. 4, 2, we had 3, 1, and he gave us 2, 0. So we draw our line through the points. What goes on each end of the lines?
Arrows.
Arrows. Now, we're not finished because we need the solution. What did we say the solution to this problem was going to be? The point of intersection, which is what ordered pair? Everybody, what's the point of intersection on this graph?
Where they connect.
No, what is the actual point of intersection? 3, 1. The ordered pair, 3, 1. Now, clear off your Desmos and work letter B with your partner. Now, looking at letter B, what form are the lines on letter B? Standard. And remember what I told you? Remember why we love Desmos? Because Desmos recognizes standard form. So you just plug it in. What did you plug in for the first equation?
2x plus y equals 5.
2x plus 5, or I'm sorry, 2x plus y equals 5. All right, Bailey, what was the second equation you guys plugged in? 3x minus 2y equals 4. Awesome. All right. Lily, what is the one point that you have to have on your paper for this problem? 2, 1. And why do I require 2, 1? Because it's the what? The point of intersection. Very good. All right, so we got 2, 1. Reagan, give me some more points on, my line is purple, so give me a couple more points on the purple line.
1, 0.
All right, and remember, you can always zoom in to get more exact points.
Okay,
We're on the purple line.
0, 5.
0, 5, good. And I need one more point. 3, -1 is another exact point. Now remember, if it's not cooperating, we can always type in a point and see if it actually does fall on the line. So 3, -1 is absolutely on the line. All right, good. So we draw our points, we draw our lines, we put our arrows on the end, and now let's talk about the black line. Kendall, we already have the 2, 1, so what's some more points we can put on the black line?
0, -2, and 3.
All right, we've got 0. If we move this around, we've got a -2 down here. Good. And what was the other one?
3, 2.
3, 2 is right here. So be careful. Remember, when you're looking for a point, it's got to be on the line. All right, 4, 4. If we type it in, let's see if it falls on the line. And it does. All right, good. So we've got 4, 4 on that one. You've got 2, 1, and you had 0, -2. All right, so draw your lines, put your arrows on the end, and finish off with the solution. Mason, what is the solution to this system? The ordered pair, 2, 1. Because the solution to a system is what, class? Everyone, the solution to a system is the point of intersection. That brings us to example 3. Everybody always wants to know, when am I going to use this in real life? So here we go. Here's a word problem. It says, write a system of linear equations. Now, if we are going to be writing a system of linear equations, how many equations are we going to write? Look back at what we've done this entire lesson. If we are writing a system of linear equations, how many equations are we going to have to write? 2, all right? So let's highlight, underline, circle. Let's make some notes as we read the problem. It says, you have a total. Now, I like the word total because it's a math word. What math operation do you think of when you see the word total?
Equals.
No. Total. Plus. Very good. So I'm probably going to make myself I'm going to put a little plus sign above that word just to help me remember in a minute that that's addition. So let's keep reading. You have a total of 18. All right. Of course, anytime we see a number, we're going to circle it because it's important. A total of 18 math and science exercises for homework. Now, it looks like math and science exercises is going to be the thing that we're talking about in this problem. But let's keep reading. It says you have 6 more. So there's another number. And there's another math word. When you see the word more or more than, what operation do you think of? Plus again. If I have 6 more than something, I'm going to be adding 6 to something. So we've got more. You have 6 more math exercises than science exercises. So there again is the word math and science. Now, what variables would you naturally think of using if we're talking about math and science? M and S. However, somebody besides Lily, what variables does Desmos represent? X and Y. So we've got to assign X to either math or science, and then we got to assign Y to math or science. So what do you want to make math represent? Which variable do you want to use for math? X. And that means we have to use Y for science. Now, let me teach you something. When you're writing a system of equations in any problem that I could possibly give you, the first equation is simply very easy and straightforward. It's usually it's usually an addition problem. Okay? What are the 2 things that you're talking about? What are the 2 objects? What are the 2 candies? What are the 2 coins? You're literally just writing an addition problem. So look at the first sentence. You have a total of 18 math and science exercises. So what do you think that first equation is going to look like?
18 X plus Y or
Milani? X plus Y equals what?
18.
There you go. You have math exercises for homework. You have science. Together, you have 18 total problems. So you take X, which is the math problems, plus Y, which is the science problems, and it equals 18. So X plus Y equals 18. Now, it's always going to be the second equation that's going to be a little bit tougher, because look what it says. You have 6 more math exercises than science exercises. So let's write down X equals. Let's talk about math exercises. It says you have 6 more math exercises than science exercises. So X equals, we've got a Y and we've got a 6. What are we going to be doing with those 2 pieces of information? If we want to, we're going to be adding them. Because if you take your science exercises and you add 6 more to them, that's how many X equals. So the second equation is X equals the science exercises plus 6 more. Now you have a system of equations. So go put these 2 equations into Desmos and graph. What's the first equation that you plugged into Desmos? X plus Y equals 18. And what was the second equation?
X equals Y plus 6.
X equals X plus 6. Now, you already probably noticed you're going to have to move Desmos around because you don't see both lines at first. All right? If I move it around, here they are. Also, since our graph is counting by 2s, what kind of coordinates would probably make our life the easiest? Even coordinates or odd coordinates? Evens. We're counting by 2s, so even coordinates. All right, now what's the most obvious and the one coordinate we have to have on our graph? What is it? What's the point of intersection? 12, 6. So we've got to plot 12, 6. Now we want to pick a point above and a point below. So give me a point above 12, 6. Let's look at the green line first. All right, that's an odd ordered pair though. You can do that, but you're going to be graphing between lines. So try to give me an even one.
14, 8.
All right, 14, 8. Y'all are on the purple line if you do 14, 8. We're trying to do the green line. The green line. It would be 14 what? 14, 4. All right, 14, 4. And again, you might have to type it in, but there's 14, 4. All right, I need one more point above the point of intersection.
10, 8.
All right, 10, 8. Let's type it in, see if it works. And it does. All right, awesome. So we've got our 3 points. Plot it, draw your line, put your arrow. Let's go to the purple line. What are some points on the purple line? Okay, we got 14, 8. Give me a point below 10, 4. There it is. Good. So we plot our 3 points for the purple line. No, make sure, what should you have been doing all along the way? As you plot points on a graph, you're also supposed to be putting what beside those points? The labels, the ordered pairs. All right, so if you've not done that, you need to make sure that you go back and do that, because you will have to do that on quizzes and tests. Now, what's the solution to this system of equations? What is the solution, everyone, to this system of equations? 12:6. However, that is not the answer we're going to box in, because this is a word problem. And the problem, if you go back to the word problem, what is the very last sentence in the word problem?
How many exercises do you have in each subject?
How many exercises do you have in each subject? So we have to make sure that we actually answer the question that it asks. So that means we're going to have to stop and think for a minute. Which type of question was represented by the X coordinate? Math. And which type of question was represented by the Y coordinate? S. So how do you think we should write our final answer?
You have 12 math exercises.
12 math,
And 6 science.
6 science. Perfect. Because we've got to make sure it's not enough to just put the ordered pair. The ordered pair means nothing when we're looking at a word problem. We have to interpret that ordered pair. So yes, it's important. It's the point of intersection, but what does it mean? It means there were 12 math exercises and 6 science exercises. And that is lesson 5.1.